Twitch. Let's go to Twitch. Let's go to Twitch. Stream. Okay. I'm just waiting until I'm live. It's like something flying. As you can see, I actually. Oh, there. I'm live. So, as you can see, I've changed my setup. So I removed my chair. My chair is right there. It's like I have a divider here, and then my chair is like somewhere there. uh, I wanted to not sit. Uh, hmm, how do I explain it? It's more like I've been working for, at least for my current job, I've been working in a company for like a year now, right? And I've been sitting down a lot, and I don't wanna, I don't wanna sit down a lot. You get what I mean? Like, yeah, like it's. I'm trying out something. Like, I wanna stand up. I wanna like while I'm doing stuff. I don't wanna sit down. Okay, because especially when you're working, you're just sitting down and you're like yeah, you're, how do you say it, like humans are not meant to sit down, okay? They're not meant to sit down for long periods of time. So what I did was like, because I have a, what do you call this, arms, monitor arms. I've bought this before, way before. I use it to kind of like make the monitor higher so that when I'm sitting down, right, it's like up, and then I can sit straight because my monitor is like up. But then it doesn't really, it defeats the purpose because I think this is what I have. Monitor stand. Mm, mm, Forgot the brand. This is what I have. What brand was it? Like Lasmol. Okay. Lazada is trying to check if I'm a robot. Okay. Mm, bus. Bus. Okay. Oh, no results. That's weird. Mm, what's the brand? Let me check the brand. Found it. This one. This is what I'm using. This is my monitor stand. I have like my work laptop here, and then my monitor, like LG monitor here on my right side. I think this is what I have. I think, yeah, this one. So yeah, I have this, right? So I use this to kind of raise my monitor so I can sit straight. But then I figured, what if I raise it way up? As you can see, it's like halfway, right? It's halfway. But like, what if I put this way up and then put everything up? Like yeah, and that's what I did. And then the issue was my keyboard, right? My keyboard now is low, and then my mouse is also low. So what I did was I have the boxes, a shoe box, the box, the Keychron box. I'll show you this one. I'm not sure if my camera can see it. But there's a little delay there. The Keychron box. So I have it there. I put my keyboard, and then I have like that's how I raised my. Currently, it's like very scuffed. My setup is very scuffed. That's how I set up my keyboard so that it's like higher and I can actually reach my keyboard, and it doesn't destroy my posture when I'm using it. And then for my mouse, what I did was my mouse is funny because I actually, what I did was like programming books. That's what I used. But I'll show you this one. Have this. Oh, I actually bought this to prepare before last year. This was last year to prepare for programming interviews. Python, because I specialize in Python. I also have this. I also have this book. Uh, cracking the coding interview. It's in Java, but I mean, you can transpose it to the language that you use, and I use Python. So yeah, I use those books to lift my mouse up, and some more boxes. You see, more boxes. Yeah, it's very scuffed. I haven't. I how do I say it? I was. I don't have enough money to spare right now. To buy like a proper stand. Because I bought something else. I think I bought a pillow instead. Yeah, I bought a pillow. I'll show you. I bought this pillow. Okay. Yeah, I bought that pillow and some bed sheets, and I'm also planning to replace my mic soon. I'm just waiting for sale. Yeah, I'm planning to replace my mic. I'm currently using the Razer Siren. This one. Actually, I'll show you guys. I'll show you guys my mic once I once I can afford it. Right now, I'm waiting. I'm waiting. I'm still waiting until it's on sale. Mm. But yeah, those are like mostly the updates that I have. Yeah, like I don't want to sit no more. There's also something that I want to do, but maybe I'll talk about it tomorrow. Yeah, I'll talk about it tomorrow. The, yeah, there's something exciting that I want to do. It's like in next year. It's for next year, and I'm gonna prep for it. But for now, let's focus on what I've been doing before, which was SQL. I want to complete that course, the CS50 SQL. I am done with problem set one, right? So today, I guess we'll just continue with I think we're in week two right now. Week two. Okay, never mind. This one. Yeah, yeah. Week two. I'm excited. Actually, I know this already. Like it's creating tables, but yeah, I want to again. I want to learn the fundamentals of SQL. That's why I'm doing this. Uh, because a lot of the things that I've learned from SQL, they're mostly from work. Yeah, yeah. They're mostly from work, and a lot of the times, when you do work, I mean, you learn a lot, but learning the actual fundamentals, it doesn't hurt. Okay, I think it speeds up how you work with, especially if I'm faced with problems with SQL in the future, it speeds up me creating tables, me writing queries, right? At least that's my goal why I took this course. And also like for me, like the most important part is the optimizing this one, right? Optimizing and scaling. I'm really excited with week 5 and week 6. Like this is the thing that I really am lacking. Right? I know how to write queries, sure, but like writing queries that don't suck, if you get what I mean, right? Like it's fast and it works on like a lot of like when you're querying like a lot of data sets, like how can you make it fast, right? Because the users can feel it, right? When your website is slow, when your backend is like querying something and it's slow, like you're doing a lot of joins. Again, a lot of this I've heard this from on my job, like when there's like technical meetings, right? You hear it a lot, right? Like what's like the best practices and stuff, but like I want to learn the fundamentals myself because I feel like I have a lot of to offer in the future if I can just learn this. Yeah. So yeah. Oh, 15.
Well, hello, one and all, and welcome back to CS50's Introduction to Databases with SQL. My name is Carter Zanke, and last we left off, we learned about relating. That is how to have multiple tables in our database for people, places, and things, and how to have them relate to one another in the way they might do in the real world. Now, today, we'll take a step forward, and we'll talk about how to put you in the driver's seat, designing your very own database schemas to organize your data. Now, we'll pick up where we last left off, which was with this database of books. So we had this database that was full of books that had been long listed for the International Booker Prize.
Wait. Let's go here. Where was it? Oh, this one. I'm first gonna go here. I'm gonna go to Z. I'm gonna go to Z, and I'm gonna this is SQL, new folder, source. I should know. Where is it? Menu, signing, and notes. No, it's not notes. Other source code. Then it's cd dot. Okay. Or minus f. Okay. Okay. There. Add source to here. Alter schema. Okay. Just gonna add this. Add this. Terminal. Feeds. Sys 50 SQL. Source 2. Source 2, right? Yeah, source 2. Oh yeah. Oh yeah, forgot. My what is it? My aliases are not working on this terminal, which haven't figured out how to fix this. Okay. Oh. That's weird. I thought git commit. Git add dot git commit minus r. Okay. Gosh, I hate it so much. My how do I say it? My aliases, they're not working. Okay, they're not working. A lot of it has to do with Z spawning this shell, which is a different shell from this shell, which is like, why would you do that? I don't know. Even though this is a login shell, I think probably this is a login shell, but for some reason it has this, which is my bash rc. This is how I set my bash rc to display the file, and then if it's a git file, then the branch, because this is not like this by default. You don't actually see this, plus this one. Yeah, it's like by default is this. No, you can actually show it. I can actually see it, but by default this thing, this $sign, will be here, but I set it to the next line, which is here. Again, it's weird because this follows my bash rc rules, but it doesn't follow my, like, see, it's not there. Hate it so much. Anyways,
Prize. To be long-listed means to be nominated for some prize, let's say. So we had the past 5 years of books in this database, and we worked on improving this database over time from week 0 to week 1. Now this week, we'll actually take a look underneath the hood and see what commands we had used to create these varied databases. So
Create
let's
table.
reveal now what we had done all along. I'll go back to my terminal here. And if you remember, I could use a command to open up a database file, which was this command here, SQLite 3, and then the name of the file I want to open. So let's try this. I'll go back to week 0, to my week 0 folder, like this, and I'll open up my long list database, week 0 / longlist.db. OK, I'll hit enter. Now, I'm in my SQLite prompt, so I could work on typing some SQL commands, SQL statements, or queries inside of this terminal prompt here. So if I want to get a feel for what's inside this database, we saw I could use a command called select. So I'll select now some rows from this table. I'll say select, let's say, the title, and also the author columns from my long list table, semicolon, and enter. Now, I'll see all the titles and all the authors that were inside of this long list table.
I hate it so much.
But I only want to peek here. I only want to see roughly what kind of data is inside, so I could probably improve this command here. I could instead say select the author and title columns from long list, but limit now to the first 5 rows we saw before. Semicolon, and I'll hit enter on this query, and now I'll see only the top 5 rows. So I'm able now to see what kind of data is inside my database. But what I can't yet see is what command was used to create this table and what kind of data could be stored inside of it. So let's reveal now what was going on underneath the hood all this time. I'll say this new command, a SQLite command, not a SQL keyword, but a SQLite command called .schema.
Oh,
.schema.
been doing this.
Now if I hit enter, I'll see the following. The command, the statement, the query that was used to create this long list table. And notice how I have many columns inside this table. I have an ISBN column, a title column, an author column, and so on. And each column seems to have some kind of data that could be stored inside of it, like text or integers or real for floating point values or decimals, if you're familiar. So this is how we created the very first version of longlist.db. But let's also see how we created the second. So I'll type .quit to leave this version of longlist.db. And now let me open up the next version we had created, which is more relational. It had tables inside of it that could relate to one another. So let me type SQLite 3, then SQLite 3, and go to week 1, and then type longlist.db. I'll hit enter. Now, I'm in my next version of longlist.db. Well, what could I do? I could type select and look at some of the tables in here to see what kind of data is inside. I could perhaps say select maybe the names from the authors table here, from the authors table, and hit semicolon. Now, I'll see all the names of authors that are inside of the authors table. I could do the same thing for books. I could maybe look at the titles of books. I could say select title from the books table, semicolon, and enter. Now I see all of the titles that are inside my books table. But what I haven't seen yet is the schema of this database. It is the way it is organized and the commands that were used to create these tables. So let me work on that now. I'll clear my terminal using Control-L. And now let me type .schema again. I'll type .schema to see what commands were used to create this database.
That's pretty interesting, right?
Hit
When you
enter,
write that schema, you
and
see the command to create
there
table
are
with not
quite a
existing.
lot of commands here. Now this feels overwhelming. I mean, I'd be right there with you, right? This is a lot of commands to parse through and read. So there's probably a better way to do this. And one way to try is to type .schema and then give it some table name. Let's say I want to understand the schema for just the books table, like just that for now. So I'll say .schema and then the table name, books in this case. Then I can hit enter. Now I'll see the schema, the organization, the command that we use to create the books table in this case. And notice again, we have several columns: ID, ISBN, title, publisher ID, and so on. Each one has their own kind of data they could support or take into this column, like integers, text, and so on. So again, what we'll do today is have you all learn how to write your very own create table commands to build your very own databases that represent what you want to represent in the real world. So let me exit this prompt here, and let me propose that we'll have a bit of a design challenge today to actually try to represent a real-world entity with some database here. And if you're not already familiar, Boston is perhaps famous for being among the first cities to have a subway system in the United States. So here is a picture from the late 1800s of a subway being built in Boston's city streets. Underneath the streets here, there'll be trolley cars would go and transport.
This like, is this 1800s? It's 2024. The Philippines still hasn't had a subway. At least, as far as I'm concerned. At least where I live, there's no subway. There's no trains here. Subway. Is there a subway in the capital? Is there... I'm curious. Is there a subway in Manila? Oh, this is the Subway restaurant. I mean the Subway. There is. Interesting. Because I know the trains in Manila, they're above ground. They're not below ground. Like you can see, there's an image here. Yeah, it's above ground. You see? You can see it. But maybe that's what they mean by subway. It's above ground. I'm actually curious. Is there a subway in... I think this is the restaurant, not the subway that I mean. Yeah, I knew it. I mean the fast food chain, I mean. Ooh, first subway. Okay. See, it's June 5, so that's why. And by 2029. Okay. Okay. See, I was a bit correct.
Here is a picture.
We're so behind, far behind the, how do you say it? The public transportation in the Philippines is one of the worst. Yeah, I would. Let me, is PH public transpo the worst? Let's see what people has to say. Yeah, ranked 58 out of 60. It's not the worst, but like we're there, okay? We're there. Okay. 25th. Fifth worst public transport. Yeah.
Picture from the late 1800s of a subway being built in Boston's city streets. Underneath the streets here, there'll be trolley cars would go and transport people across Boston. Here's another picture of a trolley actually working underneath the streets. So people would go down underneath, they would hop on a trolley, they'd be able to go to different parts of Boston, perhaps from Harvard to
Actually want
MIT.
to ride like a train, a subway, on a subway. Like I haven't done that. I mean, there's none of that here. Maybe in the future, once I travel to Europe. I don't know when that is, but someday.
Or downtown up to, let's say, Braintree, or down to Braintree, which is more south of Boston, for example. One of the famous stops is the Park Street stop, which is right down in the middle of Boston, one of the central hubs of this subway system. And now, these photos are all from, let's say, the early 1900s, late 1800s, and so on. But the subway's gotten a lot more modern since then. And actually now we have several lines that span the entire city and beyond. So here we have the red line, of which Harvard and MIT are a part. we have the green line, which brings you kind of west to east, the blue line, the orange line, and so on. So many more lines and stations have been added to this system. It's a big design challenge to represent all of these stations, all of these lines, and all of these people who might ride this subway too. So the question then becomes, how can we create a schema for this data? And again, by schema, we mean what kinds of tables should we have? What kinds of columns might those tables have? And what kind of data should we put in each of those columns, for instance, tables have? Of tables, what kind of data should we put in each of those columns, for instance? So data should we put in?
I like that SQL is strictly typed, if you get what I mean. Like when you create a table and then you specify the columns, right? You have to also specify the data type. I like that. Imagine if SQL was dynamic, dynamically typed, like Python, for example, or JavaScript. I think that would be a nightmare. Yeah. I'm glad that it has types, okay?
Each of those columns, for instance. So let me propose this. Let's say we start just first with names and stations. So Charlie here, our very first rider on this system, is going to be at the Kendall and MIT station. So this is what this table represents now. But what more could we have? Well, we might also want to have maybe what Charlie is doing at that station. Maybe he's entering the station, for instance. And if you're familiar with the subway system, you often have to pay to get onto a train or get onto the station itself. So let's say Charlie pays some fare to enter into the Kendall MIT station. Well, back in the mid-1900s, the fare was only about a dime. It was 10 cents. So we'll say Charlie paid 10 cents to enter the Kendall MIT station. And now, this seems pretty good, but if I am the transit authority, the person who runs the subway system, I probably want to know, does Charlie have enough money to get on the train? And if so, I want to make sure that, okay, well, Charlie actually could get on this train. So let's say not only does Charlie pay a fare, he has some remaining balance afterwards. So Charlie here has gotten onto the Kendall MIT stop. He's paid the fare of 10 cents and has 5 cents left. Okay, so here's a bit of a table. We could probably add more information to it. Let's say Charlie then leaves at the Jamaica Plain stop. And the fare to leave is about a nickel, 5 cents. And now Charlie has no cents left over. So again, Charlie paid 10 cents to get on, had 5 cents left, paid 5 cents to get off, and now has no remaining balance here anymore. Okay, so that's Charlie's story. Let's look at Alice, though. Let's say Alice gets on at the Harvard stop. They, too, pay 10 cents to get on at the Harvard stop, and they have a remaining balance of 20 cents. Alice will go, let's say, to Park Street, get off at Park Street, pay the nickel to leave, and now they'll have a balance of 15 cents at the end.
It's weird.
Let's go to Bob.
You're paying to enter, and then you're also paying to leave. Why would you do that? Wait, you pay. Again, we don't have subways here. So do you pay a fee? Do you pay a fee to leave a train subway? Maybe it's not maybe it's the thing, there's this thing on Subway, there's this thing on Subway where you tap your card and then there's like the thing, right? And then it opens, and then you can get in. Like it's like maybe that's what it means by like exiting the subway. It's not the train. Actually, I don't know. Yeah,
Bob enters the
maybe like it
Aleway
means
station.
the terminal, the subway terminal. Yeah, like where you.
They pay 10 cents. They have a remaining balance of 30 cents. And let's say they leave at Park Street and have a fare of 10 cents to leave because it's a further distance. Now they'll have a remaining balance of 20 cents overall. So this table is okay, I might admit. I mean, last time we learned about having what we called primary keys and foreign keys, so seems like that's missing here. Let's go ahead and add that here. I'll give each row a unique ID so I can know who entered, who exited, and so on, and give that a unique ID here. But I might even say that this table could really be improved substantially. And I want to ask you, what redundancies or inefficiencies do you see here? If we're trying to represent riders and stations, what could we improve about this design?
Uh, the people should be separate table because they don't really relate to the station. There's like there's like a people table or persons people table, and then there's the stations table, and then for each station, uh, there should be like a for each station because it's by distance, right? It's not by station. So like yeah, for the thing here. Okay, this one is a separate table. The action, there. It should be like something that the checks the distance. Because how would you know the fare? Yeah, how would you know the fare? And the balance should be should this be I think the balance is in the people. Like this is like same. Yeah, this is tied to the user. I mean to the. It could be like a separate, like for example, person and then the profile or something. Then yeah, but this thing is tied to the user. Action enter. This one is same table. This two is same table. This one is separate. This one is same. But you need to kind of something that the measures the fare per distance. I think. Yeah. Hmm. Uh,
Improved substantially. And I want to ask you, what redundancies or inefficiencies do you see here? If we're trying to represent riders and stations, what could we improve about this design?
Hello. So probably the redundancy will be the names and the stations too. For example, the Charlie will go to the train daily, then he will become most of the names in the data.
Yeah, good point. If I'm hearing what you're saying, Lauren, let me show you some examples that I highlighted here. One example could be, to your point, about these names. Like, these names seem to be telling us the name of a person, but here we have only three names: Charlie, Alice, and Bob. Well, my name is Carter, and what if somebody else named Carter also tried to get on and leave
yeah.
at some
Two
stop? Well, I wouldn't be able to
quarters.
know which
Okay.
Carter was which, or which Charlie was which, or which Alice was which, and so on. So we probably need a way to represent people and their names a little better here too. What other ideas do we have for how to improve the design of this table?
Yes, I think we can have a singular ID for a singular person. That way, we'll be better able to track their activities.
Nice. So we could probably have an ID for each person, a bit of what we learned about last week, right? Putting people in their own table and giving them their own unique ID, a primary key. Let's show that here. I'll go to some slides and I'll pick out one that shows us just riders. So to your point, Sukanya, we could try to have maybe a table for just riders. And maybe to simplify, this table has only two columns. It has a column for ID and a column for names. So here we have Charlie, Alice, and Bob all in their own table. Well, let me propose too, we could do the same thing for stations. Like let's say we have a table of stations now, and we give each one their very own ID as well, our own primary key for this table. We have Harvard, Kendall, and Park Street, but we can differentiate between them using their IDs here. So a few improvements could be made, and as we're making these improvements, splitting one table into many, and debating what kind of data to store in each table, the process we're going through is one called normalizing. We're normalizing our data. To normalize means to reduce redundancies effectively, to take a table, take one table, for instance, split up into multiple, and have each entity a table or data. To normalize means
redundancies.
To reduce redundancies effectively, to take a table, take one table, for instance, split up into multiple, and have each entity a table, take one table, for instance, split up into multiple, and have each entity be part of its very own.
Actually, I don't need that. It's normalize means to reduce redundancy. I think I can understand that.
Some academics in the world have named different normal forms, quote unquote. There's like first normal form, second normal form, third normal form. This progression of making your data more and more efficient, you can use those as heuristics, but at the end of the day, a few principles might apply. First, take your entities, like in this case, stations and riders, and put them each in their own table. And if you add more data, make sure that if I were to add a column, let's say to riders, it is only a data point about riders, not about stations, not about fares, only about riders. And that process can help us make a data set that is more dynamic, more easy to reproduce, and more easy to write queries on.
Makes
so that is the process here of normalizing. Okay, so if we have now riders and stations, we want to represent them in our table. Well, we could use what we learned about relating last week to ask how could we actually represent these riders and these stations. So let's say here, I again have riders and stations. I want to make sure that I have the right relationship between them. Well, if you're familiar with subways, we might say that a rider goes to one station. And this big T here is the symbol for a station here in Boston, for the T is what we call it for the subway. So a rider might go to one station. But of course, that might not be the full picture. A rider also gets off at some station later on. So a rider could be associated with not just one station, but multiple. And if you're familiar, at least with any subway system, really the Boston one too, it can often get pretty busy. And so riders might not just go to, of course, one station or two. Stations could also have multiple riders that are on a particular station here.
It's like...
So to recap, one rider might be associated with more than one station. They might get on at this first one and get off at this later one. But each station could presumably have more than one rider. Each station here could have rider A or rider B, the rider up here or the rider down below, and even many more than that as well. So to put it in the language of our ER diagrams, our entity relation diagrams from last week, we could look at a bit like this, where we have riders and stations. Riders visit stations, and they're associated like this. A rider must have at least one station associated with them. That's what this horizontal line means. If they aren't at a station, they aren't really a rider, right? A rider, though, could have many stations associated with them. That's what this 3 prongs down here means. They could have 1, 2, 3, 4. They could have many stations they get on and get off of. Now, a station could have anywhere between 0 riders if it's maybe out of commission or isn't very popular, upwards to many. It could have 2, 3, 4, 5, even hundreds of riders associated with this particular station. So here is our entity relationship diagram for these particular riders and these stations here. So let me ask, what questions do we have on these relationships between riders and stations, and how to design this table so far?
Sir, I want to ask that you have used the same ID for stations and riders, so that maybe give us problem in coding.
Yeah, a good observation. So you might have noticed that in the riders table and in the stations table, I
So
gave
separate
the
tables.
same kind of ID. Like I had 1, 2, 3 for each of them. And let me just show you that again here. I'll come back to some slides. And I'll show you again the riders table where we had Charlie, Alice, and Bob, ID 1,
It's not a problem
2,
because
3.
they're two separate tables.
Same for the stations. We had stations Harvard, Kendall, Park Street, ID 1, 2, 3. And to your question, isn't that a problem? Well, I would argue in this case it's not, so long as we keep clear that these IDs are for stations and these IDs are for riders. And we'll see how to do that using our SQL keywords later on. But again, so long as we have an ID just for our riders and an ID just for our stations, we can keep these separate even if they might have the same values. But a great question here. Let's take just one more.
Regarding the entity relationship diagram, how is it possible for stations to have a possibility of 0 riders, but riders must compulsorily have at least one station?
Yeah, good.
He already explained it before that it can't really be called a rider if you never went to the station. So yeah, that's why a rider must have at least one. I mean, the relationship between the rider and the station, for them to be called a rider, they must have been to a station. But the thing is, a station is still a station regardless whether a rider entered or exited or not. That's why in the relationship between the station and the rider, a station can have 0 or more riders, I think.
A good question. So this might be up to you and how you formulate it, but for me, let me show the diagram again. I'll go back to over here. In my mind, to be a rider, you have to have visited a station. If you aren't visiting a station, you aren't really a rider, right? Now, presumably, there are stations that were built but aren't really being used right now, or aren't really in service yet. That could be a station that has no visitors. So you could argue, let's make sure every station has at least one rider, and every rider may or may not have to visit a station. For that, I would say, we could probably reasonably disagree there and talk about how we could represent the diagram here too. But a great observation and a good other critique of this system here. All right. So let's now turn to representing this in our database. So I'll go back to my computer, and we'll learn about this new SQL keyword, SQL statement, this one called create table. Create table allows us to, as the name suggests, create a brand new table. So let's do just that in our new database to represent riders and stations. I'll go into my terminal, and I want to make a brand new database. I'll call this one mbta.db, because MBTA stands for the Massachusetts Bay Transportation Authority, the people who run the subway, essentially.
How do you
So I'll
create
do
a database?
SQLite 3 mbta.db, hit enter, and I'll type Y to say, yes, I want to create this brand new database. Okay.
Wait. MBTA means
MBTA.db, because
Bay
MBTA
Transport
stands for the
Authority.
Massachusetts Bay Transportation Authority, the
Transportation,
people
okay,
who
okay.
run the subway, essentially. So I'll do SQL.
Wait. Okay. Oh, it just auto creates it. Okay. Never mind.
SQLite 3 mbta.db, hit enter, and I'll type Y to say, yes, I want to create this brand new database. Okay. Now, if I type dot schema, I see nothing, but that's expected. I don't have any tables yet. I have nothing inside this database. It's up to me to create these tables myself. So what I'll do is clear my terminal, and let's start first with riders. I might create a table for riders. I'll say create table. And now I have to give that table some name. I might call it riders here. And then in parentheses, like this, I can specify what columns should be part of this table. So let's start first. I'll hit enter here and continue this query. Now, I'll, by convention, just indent 4 spaces, 1, 2, 3, 4, and I'll give an ID to each of these riders, as we saw before. I'll say ID here is one of my columns. Now, to create a new column, I'll follow this up with a comma and hit enter. All again, by convention,
I don't know,
for
there's
style,
no string.
just indent 4 spaces.
I think it's like
And what's my next column? Perhaps
varchar?
a name for these riders.
No, let's just do
I'll give
text.
this column the name, and I'll leave it at that. Once I'm done adding columns, I no longer need to have a comma. I could simply close out this query, this statement. I could hit enter here, say close it parentheses to close the top parentheses here, semicolon, hit enter,
How do
and now
you...
nothing seems to...
Let me just check real quick. SQL create table. I forgot how to do the primary key thing. The primary key. Yeah, SQL primary key. Okay, and auto increment, but it's, I think it's automatic primary key. ID something. Why is it wrong? Oh, okay. Okay, did I save my stream? Let me check. OBS died. Sorry. Okay, I'm back. And then my bad. Semicolon. It shouldn't be text. Probably should be varchar something. 64.
to happen. But that's actually a good sign. So let me type dot schema, hit enter, and I'll see the result of that statement before. Create table, if it doesn't already exist, riders. And riders has inside of it 2 columns, ID and name.
Okay.
Okay, let's keep going. Let's make one for stations too. I'll clear my terminal and I'll say, create me a table called stations and include, actually not station, if you ever want to, let's say, fix this kind of table here, let me try closing the parentheses, hit semicolon, enter. I'll get a syntax error. I can restart. I'll do Control L. Now I'll do create table stations, plural. Open parentheses, enter. I'll indent by 4 spaces, 1, 2, 3, 4. And now I'll similarly include an ID for each of these stations. I'll say ID, comma, and then what else should I have? Well, stations tend to have a name, like the Kendall MIT station, the Harvard station, the Park Street station. So I'll say, I'll give each of these their very own name, comma. What else do stations have? Well, they might also have a line that they're on. Let's say it's the red line, or the blue line, or the green line, and so on. I'll have a space for them to write in their line that they're a part of. Okay, and maybe I'll leave it at that to keep it simple. I'll say stations have an ID, a name, and a line. Now I'll close this out. I'll say end, parentheses, semicolon, hit enter, and nothing seems to happen. But if I type dot schema, I'll now see my riders and my stations tables inside of my database. Now, one more step here. We have riders, we have stations, but we have to relate them. We have to relate them using this many-to-many relationship as we saw last week. So let me try making a table to implement this many-to-many relation.
This is how you write migrations in SQL. Exists writers. Yeah, that's why I can just run this over and over again. Yeah, and that's schema. Okay.
Relationship. And if you,
and for example, if I want to change this to 64, and that schema, it works. Okay.
Remember, we might call this kind of table a junction table, an associative entity, a join table. It has a lot of names, but it looks a bit like this. I'll create this new table to represent, let's say, visits. A rider visits a station. So I'll call this table visits. And inside, I'll make sure it has two columns. One for a rider ID to represent a rider, and one, let's say, for a station ID to represent a station. Now, when I see a rider ID next to a station ID in this table, I'll know the rider with that certain ID.
I think it's in not now. Station ID. Station ID. And not now. Then I think it's like foreign key. Foreign key references. Foreign key rider ID. The references. I think it's something like this. References, riders, and then ID. Is this something like this? I forgot. Is this like this? I forgot the syntax. Okay, I forgot the syntax. SQL foreign key. Foreign key constraint. Foreign key rider ID references. Yeah, I'm correct. I'm correct. Rider's ID. Yeah, that's correct. Yeah. Station. Station ID. Okay. Schema. Okay. Yes.
Visited the station with that certain ID. So I'll close this out. I'll say end parentheses here, semicolon, enter, and finally clear my terminal, type .schema, and I can see I have riders, stations, and visits between riders and stations in this associative entity, this junction table or a join table, up to you what you might want to call it in this case.
You can actually create
Now,
a table without a
what
type.
questions do we have?
Why we have not used the
With SQL create table without type. This is weird. I thought that you have to add a type. Yeah, yeah. It's in data types. That's why I was wondering, why does it work for him? It's weird. Maybe it's something,
primary
yeah,
key and secondary key.
something with
This
the
table.
SQLite that he's using. Because again, before on the previous lectures, he was able to do like a right join on SQLite, but that's not possible on SQLite. Maybe it has something to do with
Good question. So we're going to get
what
there in
he's
just a
using.
minute. But if I look back at my terminal here, my schema, I'll see I really just have columns.
Yeah, there's no data type.
And we
Like,
saw before when we typed .schema on our long list.db, we had more than just column names. We had column names, we had perhaps data types, we had primary keys and foreign keys. So we'll get to that in just a minute, but suffice to say for now, we're going to keep improving this over time. Let's take one more.
Is it required to put spaces, the 4 spaces, the indents, or that's just for the
just
visual
for
look?
style.
Yeah, great question. Is it required to have these 4 spaces
It's not
before
required.
each column name? And in fact, no, it's not, but it makes the code more readable. So if I could put this all on one line. I shouldn't, but I could. And if I have instead this new line followed by 4 spaces, I can make this more readable for myself and for my colleagues too. Good question. Okay, so to our earlier point, there are things that are missing from this schema. Like we have column
Which is still
names,
unstable,
but as we saw
but at
before,
least it's up.
we should ideally specify what kind of data should be able to go into each
I'll end the stream here halfway, okay?
of
The stream after
these
this.
columns. And for that, we'll need some new ideas to talk about here. So let's focus now on this idea of data types and storage classes. Data types and storage classes are two very similar but distinct ideas, and they're distinct in a way we'll talk about in just a minute. Now, SQLite has 5 storage classes, 5 kind of storage, 5 kind of types, so to speak, of values that can hold. So let's talk about the first one, null, for instance. Null, in this case, means nothing. There's nothing that actually is inside of this value. It's kind of a sentinel value to mean nothing is here.
Okay.
Integer means types, so and their storage classes are 2, and storage classes. Let's focus now, and for that we'll need some new ideas to talk about here. So let's focus now on this idea of data types and storage classes. Data types and storage classes are 2 very similar but distinct ideas, and they're distinct in a way we'll talk about in just a minute. Now, SQLite has 5 storage classes, 5 kind of types, so to speak, of values that can hold. So let's talk about the first one, null, for instance. Null, in this case, means nothing. There's nothing that actually is inside of this value. It's kind of a sentinel value to mean nothing is here. Integer means a whole number, like 1, 2, 3, 4, 5. Real talks about decimals, like floating points, like 1.2 or 2.4, and so on.
All is nothing. This is small numbers. This is decimal. This is provide 3 plus 5 classes.
Text is used for characters, and blob, kind of a funny one, blob stands for binary large object, and it represents
It's my first time knowing the meaning of blob. Yeah, I know I know what blob is, but like it's the first time that I actually knew the meaning of blob. Binary large object, okay. I know it's bits, something about bits, yeah. It's interesting. Blob. Binary large objects.
the data exactly as I give it to this value. If I tell it to store 101010, exactly as I very large object, and it represents the data stands for binary large object, and it represents the data exactly as I give it to this value. If I tell it to store
Just like a string literal.
the
Literal
data
string.
exactly as I give
Presents the data exactly.
it to this value. If I tell it to store 101010, it'll store exactly 101010 in binary. So useful for storing, in this case, like images and video files and audio files, things that
What do you
have
mean?
some structure we don't want to mess around with.
Okay, interesting. It's my first time knowing about
Now,
blobs.
let's focus on this
I mean,
idea
the meaning of
of a
blobs and stuff.
storage
Like, I
class.
just know that they exist. I use it. But I never really knew what they're
These,
for.
I'll say, are storage classes and not data types in SQLite. Now, a storage class, like integer, can hold several data types.
0 bytes.
Notice how there are 7 different data types that could be stored under this integer storage class. We
1
have
byte
a
is
6-byte
8 bit.
integer, a 2-byte integer,
1 byte is 8
8
bit.
and 0, and so on. It could be any of these particular
I think.
types.
With let me check. 1 byte is 8 bits, right? Okay. I was like doubting myself.
These types under the umbrella of this integer storage class. And SQLite itself will take care of making sure it uses the appropriate data type. Like if I give a very large number, like let's say 4 billion or 6 billion or even bigger than that, it'll probably use a longer, that is a bigger byte integer to store that kind of value. If I give it a smaller one, like 1, 2, 3, or 4, it'll probably use a 1 byte or a 2 byte integer for that. But SQLite's idea is that I, as a programmer, shouldn't have to care if I use an 8 byte or a 1 byte or a 2 byte integer. I just care that I'm using integers, whole numbers. And they give me a storage class to use any of these up to their choice here as well. Now, let's look at a few examples of values in SQLite that we could store. Well, we have perhaps the red line as some text. And because this is characters, it's quoted, we could use the text storage class to represent this particular value here. We could have maybe an image. And to the earlier point, we could say, well, this image might be best represented using a blob, a binary large object, to keep all of these pixels exactly as they are in this image.
But you wouldn't want that.
Some choice, some interesting.
You shouldn't store images in a database. You should store them separately. Yeah. Like usually you use like AWS S3 Pocket, or you could store them like, I don't know. Like if you have like your own self-hosted one, you don't typically store disk images on the database because this could get really big, and you wouldn't want that. Because yeah, I think databases are like they're best there to represent like data and like text and numbers, right? Like things that you can query fast. This one is like when if you try to query like a very large image, like it will take a lot of computing power. That's why you don't store it on databases.
Challenges. We look at the idea of fares. So let's say, to our point earlier, fares are 10 cents back in the 1950s or so. Well, 10 cents we could store as an integer, which seems just fine.
I think it's better to store it as decimal.
This could get confused. I'm talking about dollars here or cents. Maybe it would be better, let's say, if I did this, a $0.10.
You want to store it as a text?
And what might that be stored as?
No,
well,
it should be decimal.
Probably text, right? I could say this $sign isn't really a number, but now I have to include it. So I'll say this will be quoted essentially as $0.1.
You could name the column in dollars.
Now there's some downsides here too. Like let's say I have I want to add these up. Well, I can't add up text. Like,
Yeah,
what does
it's
it
a
mean to
problem.
say $.10 plus $.20? I can't do math with text. So maybe it would be better, after all, if I used a real or a decimal like this, 0.10. But I mean, even here, you run into some problems. If you are familiar with how these numbers are represented in binary, you might know that decimal values or floating point values can't be perfectly precisely represented. And if I talk about 0.10, the computer might store 0.100000567889. It could get very wonky out to the many, many decimal digits
You can
down
control
below
how many
here.
decimal
So
points.
trade-offs and challenges overall. Let's look at these three, though. I have the first one to store as an integer. I'm trying to store fares here. Second one as text. And the third one as a floating point, or a real in this case. Let me ask for some opinions here.
Go
Which
with
one
real.
would you use, and why? If we're trying to represent fares in this case.
Thank you. I prefer using integers
No,
because
integers are bad.
of course I need to get the calculation very accurately. That's my point of view. Well, sometimes I can use floats, but like you said before, it can get very wonky if I get, if I really need that kind of precision. I
We're
don't
dealing
really
with money here. That's why integers are bad. Yeah.
recommend using floats.
Yeah, good point. So to go back to some slides here, you might argue for the integer because you know you can precisely represent integers. And let's say I want to add up fares over a lot of riders. This might be useful for me because I know that each number will be perfectly precisely represented. I can do lots of big kind of math with this number here. To your point, this decimal might kind of, as you should, get wonky later on towards later decimal points. I might get some unexpected results if we add up these overall. Let me ask, though, are there any proponents of this floating point value or a real value?
Okay, so I think the float is in the number of, for example, for each pair, like the answers in the chat, like truncation probably suggests one of the comments there.
Yeah, good point. So if we talk about using this float value, I mean, one thing we could say for it is that this decimal could be, it's more accurate to say, like, we're working with dollars now, and we could have maybe 10 cents, which is only 0.1 of a dollar. I totally hear that point as well. And the point we're making here is that they're really just trade-offs among these data storage classes to use, whether you're using integers or real values. It just depends on your use case and what you're designing for. So be sure to read up on trade-offs among these data types and determine for yourself which one should you best use.
Okay. Now, if you're dealing with money, should you represent it with? I think it should still be decimal. Yeah. Dealing with currency, should you store it as int or real or float? SQL. I think it's float. Wait, really? Really? Interesting. Integers. Always use integers. Yeah, fixed point. I was thinking like decimal, like do T decimal points. Interesting. Interesting. I actually don't know. What's the best practice? Yeah, what's the best practice? Big int. Let's ask ChatGPT. Just still up, it's just unstable, okay? It's not my fault. What is the best practice? Integer. Yeah, fixed point decimal. That's what I was thinking. Decimal issues. Okay. Current company, we don't. It's not a fintech, but I don't think we deal with money. Maybe for taxes. I don't remember. Yeah, it's mostly. Yeah, I don't remember we deal with like storing money in the database. In the database. Yeah, my previous company though, it was a fintech company, but forgot what they used. Forgot what they used to store the money. I mean, I worked on some parts of it where I actually saw the schema because I had to write some SQL queries, right? I had to write because I had to display data on Metabase, but maybe because the existing query was like so overwhelming. Like this one is like simple to read, right? But the one that they used to display data, right? Because it was so complex that it was like a lot of the stuff that you read it goes over your head. Yeah. Yeah, actually it's actually hard to read. Yeah, like you have to really read it. It's not something you can just see first glance and know what's happening. Yeah. And they use like version control on the thing. Like they add like for example, this author changed this line on this. Yeah. And there's like a history where you could also check who changed who. Yeah. It's interesting.
So we
Integer.
have now
Interesting,
these
integer.
storage classes to store values, and it turns out that columns can be made to store certain storage classes or prioritize certain classes. And the key distinction here is that columns in SQLite don't always store one particular type. Instead, they have type affinities, meaning that they'll try to convert some value you insert into a given cell or a given row to the type they have the affinity for. Now, there are, let's say, 5 type affinities in SQLite. Text, columns can be of the type affinity text, meaning they store just characters at the end of the day. There's also numeric, which stores either integer values or real values, depending on which one seems best to convert to. You have integer type affinity, which means it'll store whole numbers, real to store floating points or decimal values, and we have blob here again, our old friend, to store binary exactly as we get it. So whereas before it also be to the type they have the affinity for. Now there are, let's say, 5.
This is the first time that I know that I'm seeing all this. Teacher.
type affinities in the insert into that or type columns or prioritize columns storage classes to store values, and it turns out that columns storage use. Offs among these data types and determine for yourself which one should you best use. Okay, so we have now these storage classes to store values, and it turns out that columns can be made to store certain storage classes or prioritize certain classes. And the key certain storage classes or prioritize certain classes. And the key distinction here is that columns in SQLite don't always store one particular type. Instead, they have type affinities, meaning that they'll try to convert some value you insert into a given cell or a given row to the type
Wait,
they have the affinity.
Does Postgres and MySQL also have type affinities? This is the first time I'm hearing all this. That's why I'm kind of confused right now. This is new information. Wait, is type affinity? Hmm. Okay, okay. That's why. What? It's an int. What the hell is this? Hmm. Okay. Oh, wait, I mean, it makes sense. It makes sense. It makes sense. Because the query is a string. This one, like, right? If you, yeah. That's why it makes sense that it converts it to int, tries to convert it to int. What I mean is, what I mean is that if I have like, let's say, Z, let's go to Z, right? Let's do like Python. Main is just some. I don't have my snippet. Why don't I have my snippet? Maybe Py. No. I don't have my snippet here. This is weird. I don't, wait, what? Snippets. Oh, I only have Go. I hate it so much. Why don't I have Python snippets? Could I do this now? I can go to my VS Codes. Shift N. Control KO. Repos. Anyone, maybe. No, let's do mail. No, let's do something. Yeah, let's do mail. It's in Python. And then and then snippets. Python.json, and then just copy this, and then paste this. Terminal, touch, Python. Python.json. Okay. Okay, and then I need to check the format thing if it's the same, because there's a lot of tabs. Okay. The file is denied. Why do I have Firefox open with another view all applications? Where is my viewer? Sublime text. What viewer is this? Text editor select. Okay, there. Scope. I don't need the scope. Okay, I don't need the scope. Okay, I don't need the scope, right? It's just body, prefix. Yeah. Okay. Okay, I think that's it. And then I just need to restart my Z. I just need to restart my Z and it should load the snippet, right? There. So I have this, right? Let's just say I have, because currently I don't have a, how do I say it? Should I show it? SQL Python. What do I need to install? I need to. Where's the thing? Okay. Oh, you could do double click. That's interesting. I'm learning new things. I'm learning new things. I'm learning SQL Python. So VE, right? VE, and then oh no! Oh, I hate it so much. Hate it so much. I hate it so much. I do not have access to it. So what I'm gonna do instead is I'm gonna do this. I'm gonna cd documents repos courses, and then v there. Then I have, what is this? cd cs50 SQL. So, and then I'm gonna pip install SQLi3, right? SQLi3. Where is this? Pip install SQLi. Recall name. Pass. Recall SQLi3. Okay, and then defaults. Where is the thing? Ah, it's in source 2. So I'll just do like a test.db, maybe, I don't know. SQLite 3, okay, pip. I'm doing a side quest here, okay? I'm doing a side quest here, just to prove a point. I shouldn't. Never mind. It's taking a while to upgrade SQLite 3, SQLite 3 test.db. Okay. Okay. Now I have it, right? I have it. Why don't I have it? Alex. No. Alice. It's not here. Interesting. Minus y? That's schema. Okay, you need to run a command. It's here. Okay. And then in my query that SQL, I'm going to just do this. And then I'm gonna insert some values to, let's say I'm gonna insert into let's say writers, right? Let's say writers. Insert into writers. How to do it again? Something insert into writers, and then the okay. The column names. Insert into writers the column names. So ID. Insert into writers ID and name, and then values. I think it's like this. Is, let's say, I don't know. I don't need the ID. Insert into writer's name, because the ID is primary key. Let's say values is John Doe. So yeah, I'm just gonna copy this, and I'm gonna do this. Okay, John Doe. Oh, it's not null. Constraint failed. Where is that ID? But it's a primary key. That's weird. Maybe auto increment. That's weird. No. Wait. I know that this is SQLite, the SQL primary key, not null, auto increment. I know it's like by default it has these traits already. Okay. Auto increment. Maybe I have to add this. Do I have to add auto increment? Yeah, add auto increment primary key. Okay. I thought that you did not need it. Okay, I guess you need to add it. Thought you did not need it. Table. Especially if it's like a primary key. I really thought that you did not need it. Primary key. Interesting. Interesting. And it's underscore. Okay. Syntax error 1. Why? SQL. Maybe because the syntax of SQL 3. Maybe. Okay, it's not with underscore. Hmm. It's because again it's a different flavor of SQL. I'm really confused right now. Why is it not working? The increment. It's correct spelling, right? Increment. Maybe I should not put not null. But it should be not null though. Okay. Schema dot selects star from writers. And that's so weird. So weird. It should have an ID. Maybe I'm doing it wrong. Yeah, it's something. Yeah, it's like this. I like auto increment because it doesn't reuse IDs. It just, just keeps on going. It causes a problem when you try to query something that you did just deleted, right? You want a unique ID for the next insert. But it is. Oh, integer, not int. Okay, so can I do this? Does this work? It doesn't work. It has to be primary key. Okay. What do you mean? Integer primary keys. Why would you do that? Why would you hate it so much? Why would you insert null as an ID? Okay, we're just not gonna add auto increments because that's so weird if you need to insert the ID as null. I think this is just a problem with SQL. I don't see this ever happening on something like Postgres or MySQL. It's still wrong. Why is it wrong? Why is it wrong? I'm so confused right now. Oh, okay. Wait. I'm so confused. Why is this wrong? SQL. Let's get Ah, shish. Oh my god. I hate it. I hate myself. Okay. So let's start from providers. Okay. Close enough. So what I was trying to say is you have this, right? And then I want to create a connection. I'm gonna create a connection. Little side quest here, little side quest. Python SQLite. Let's first create a connection. So tree that connect. And then this is test.db, right? And then let's see if equals conlet cursor. Why is it not? Con is con cursor. Okay, and then curl execute. This is where we write the SQL query. Curl execute. Let's say dot schema. No. Select star. Select star from. Oh no. Let's do this instead. Let's start from so let's start from writers. Okay, let's have this. And then we have rows here, rows, and then if rows, print rows. Actually, no, we can just print rows. But no, just yeah, you can just print rows. And then then where's my thing? I may. Okay, why am I printing the cursor object? I forgot. Keep on forgetting. Okay, then rows equals that fetch all. Fetch all, because it's a lot. And then I main should return nothing. Why did it return nothing? Huh? That's that to be right. Maybe I need to exit. Can I? How do you check if? How do you check? How do you check if I've connected? What SQL tree? Python SQL. How to check if connected to DB? Oh yeah. I also need to close it. Close. Maybe that's why. Is this why? This is why it's not working? Okay, still down. And just do db that cursor, yeah. But there's a cursor object, meaning it's connected. Why did it throw nothing? Why did it throw nothing? Do I need to do that? Confused. I'm really confused. I'm really confused. Oh wait, what do you mean? No, 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 this. Oh. What the hell? Hated someone. Why is it empty? Wonder why. I really do wonder why. No, there's no locking issue because I'm not opening the thing. Maybe I'll do this. Then migration. Insert time you have to commit the thread. Commit. db.commit. How about this? Oh, you can only. Okay. Migrations. Oh, that sucks. You can only. Yeah. No, 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 no. I know what to do. I know what to do. I know what to do. And migration that split. Okay, there. It's weird. Where's test.db? Weird, it's weird. Okay, so now I have this, right? I know it took me so long to get this. So like this is the ID and then this is the name, right? Now I have it. So what I was trying to say is why the implicit type conversion is important, because for example here, as you can see, the query, the SQL query is a string. It's in string, right? So like if I do like a specific query, right? Like for example where ID equals something, right? We don't know, and then we pass in the ID. We pass in that ID, let's say 1, right? This is an integer, right? This is an integer, and this will be passed in as an integer. But then, if you think about it, right? This is a string. This query is a string. That's why I think it's important to kind of implicitly convert it to string. Some things like, for example, what if this thing is like from request, right? Request that values, for example. Let's say, for example, it's from a get request, right? A get request. So let's say, for example, I have like localhost 5000, and then we have the thing, right? And then we have ID equals something. Let's say 1. ID equals 1. This thing, and then you're parsing this request parameter, right? This ID. But whenever you parse a request string, I mean a query, right? What do you call it? Request query parameter. I forgot what you call it. Query string. Like, but this is a string. So whenever you get the 1, even though we know that this is an ID, but trying to get the ID, right? But whenever we're getting the value from the query, it's always a string. It's always a string. So, for example, this will be like 1, for example. If we try to get this from the query, right? It will be like a string of 1. Sometimes it's like, of course, you can always convert it like int 1. You can always do this, right? You could do that, or you could also just directly pass in the string 1 to this placeholder, and it would still work. Like, I'll show you, it would still work because of the implicit, because of the type conversion. Why did it not work? How do you do placeholder? How do you do placeholder in SQLite? SQLite tree placeholder. I thought it was this $S is for MySQL. Is it question mark? Okay. String formatting. Okay. Yeah, I thought you could do the string formatting. Yeah. Confused. Okay, it's question mark. I know this is possible for MySQL. Yeah. And I'm not lying. I'm not lying, okay. That's a MySQL. Reset. Select. It's not here. What did we use? I have a feeling it will also use the question mark for placeholder. I know it's possible to use the %s. See, this is what I mean. It's using %s. It's not using placeholder, so I'm whatever. Whatever. This should work then. Okay. See, it still works. Even though we can clearly see that the ID is an int. It doesn't have the string, the what do you call it? The double quotes. This is an int, but we can query it as a string because this is a string. This is a string. But that's why I get why this is done. I get why this happens. I mean, this thing, where is it? This thing happens even on other databases, not just SQLite. It also happens in MySQL and PostgreSQL. But it's interesting because like the first time I saw this, why would you do this? And then I thought about it, like how you write the queries, and oh, now it makes sense why they do it, why it's done this way. It's interesting. It's interesting.
Affinity for. Now, there are, let's say, 5 type affinities in SQLite. Text columns can be of the type affinity text, meaning they store just characters at the end. Now, there are, let's say, 2, the type of some value you insert into a given set. Instead, they have type affinities, meaning that they'll try to, instead SQLite, don't, and the key distinction here is that columns in SQLite don't always store.
Also in some
one particular type. Instead, they have type affinities, meaning that they'll try to convert some value you insert into a given cell or a given row. Instead, they have type affinities, meaning that they'll try to
convert some value insert given what?
Convert some value you insert into a given cell or a given row to the type they have the affinity for. Now, there are, let's say, 5
To the type they have affinity for.
type affinities in SQLite. Text columns can be of the type affinity text, meaning they store just characters at the end of the day. There's also numeric, which stores either or just characters at the end of the day. Columns can be of the type affinity text, meaning they store just characters at the end of the day. There's also numeric, which stores either integer values or real values, depending on which one seems best to convert to. You have integer type affinity or real values, depending on which one seems best to convert to. You have integer type affinity, which means it'll store whole numbers, real to store floating points or decimal values, and we have blob here again, our old friend, to store binary exactly as we get it. So whereas before we were talking about storage classes, those are associated with individual values. Type affinities are now associated with individual columns.
Constraints.
So
okay.
let's see some example of how this might work in SQLite. Let's say I have this table of fairs, and we've decided to store fairs as integers.
Okay.
Well, if I said that this column called amount has the affinity for the text storage class, what would happen is if I insert this integer 10, it would look a bit like this later on. It would be converted to text be quoted in
Interesting.
this sense to represent is now been converted to some set
I
of
never really
characters.
thought that it works that
Let's say
way.
I insert this
I never really thought about it, but it makes sense.
value 25. Well, 25 has a storage class right now of an integer. It is a whole number. But if I insert this into a column that has the text affinity, it'll be converted into, in this case, text at the end of the day.
I'm just gonna finish
Let's
this.
do the opposite. Let's say I have my fare as a string, some text in this case. I want to insert it into this column called amount, but now amount has the integer type affinity. Well, if I insert 10, quote unquote, into the column amount, I'll get back not 10, the text, but 10, the integer. Because again, amount, this column here, has an affinity for the integer storage class. Let's try this. 25, some text again, I'll insert it into this table. Now I'll have 25 as an integer. So this is how SQLite allows us to give certain columns an affinity for certain types, that they'll try to store values of that type so long as we insert values that could be feasibly converted to that type here. So let's go back to our schema and try to improve it now to use not just column names, but also type affinities to store certain data of a certain type. Go back to my computer here, and let's improve this once more. So I'll go over to my table. And now I probably want to improve the design here. And often, if I want to improve this, I might
Okay.
just need to erase what I've already done. So let me introduce this new keyword, this new
It's not
statement
identified.
called drop table. To drop a table means to delete it, to remove it, effectively. So let me try doing this for riders, stations, and visits. I'll type drop table riders, semicolon, enter. Nothing seems to happen, but if I type dot schema, well, riders is gone. I'll try drop table stations, then semicolon, hit enter, and type, let's see, dot schema again, no more stations. I'll try drop table visits, semicolon, enter, and then dot schema, and our database is really gone. There are no more tables inside of it. So let me propose that instead of working inside of the SQLite prompt, like typing out again and again and again, create table riders, create table stations, create table visits, let me be a little more efficient about this and create myself a schema file that I could reuse throughout this lesson and also later on while I'm working on this database on my own. To do that, let me quit my SQLite prompt here, and let me type something like code schema.sql. I'm just creating this file called schema.sql. Now, a .sql file allows me to type in SQL keywords and have them be syntax highlighted so I know what's going on inside of this file. So let's just try this once more. I'll type create table riders,
schema.
and inside I'll say it has the ID column of what type affinity. Well, IDs are whole numbers, so perhaps integer in this case. I could say ID has the integer type affinity. Now, let me say that riders also have a name. And how could names be best represented? Maybe text, right? Characters here. So I'll say name and text. Now, I'll include a semicolon to say this is the end of my create table statement. And before, remember how I had to kind of error out, or I had to like backspace and so on to improve the design, here I can literally just point and click and edit this file to improve my schema. And I'll later on apply this in my database using a command that we'll see a bit later. So let's keep going here. I'll say create table stations, and inside of this stations table, I'll make sure it has an ID column of type integer, a name column that probably stores some text, and a line column that also stores some text, where name is the name of the station, like Kendall MIT, Harvard, and line is blue line or green line, what line it's part of in our subway. Let me try now visits. I'll say create table visits, and then I'll do rider ID, which has what type affinity? Probably integer. And then I'll do station ID, which has this same type affinity. We're talking about integers, whole numbers here for IDs. Semicolon to finish this statement. Now this is my schema as a whole. I have riders, stations, and visits. But now I want to apply this schema to my database. So what could I do? I could reopen it, let's say. I'll do SQLite 3 mbta.db in my terminal. And now I want to read in this schema.sql file. That is, run the commands that are inside of this file. So what could I do? I could say .read schema.sql, where .read is a command that says, take whatever file you give me, like schema.sql, and read it into this database, running any SQL keywords you come across there. I'll hit enter, and now nothing seems to have happened, but if I type .schema, I now see my schema improved. And this is helpful for me, because what I could do now is I could just edit my schema.sql.
Interesting, that's interesting. Okay. That's MBT. That reads that's and select stuff from this. Interesting.
File and rerun it to make sure I now have these tables being improved over time. Okay, so this then is our new representation of our database. We have riders, of course, their own entity, and stations. They have an ID and a name, and stations have an ID, a name, and a line. We've also now included these type affinities, integer, text, to tell SQL what kinds of storage classes could be put inside of each of these columns. Now, before we keep improving this, let me ask what questions we have on these storage classes and type affinities.
Sir, you were using when you were creating the table was not in the line. So when we search for the authors or books, so it comes with a perfect table. So how can we make a perfect table in the SQL?
Yeah, do you mind clarifying what you mean by like the perfect table?
Sir, I mean that it was arranged in something like in boxes.
Ah, good question. So before we were able to see the results of our queries inside some boxes in our terminal. And that is actually a mode of SQLite. I think you type like .mode table to see your results in that version. Here, though, we have no data inside of our tables, so we can't really select anything from them. Like if I go to my terminal here and I try to select some data from this riders table, let me say select star from riders, semicolon, I won't get anything back. Next week, though, we'll see how to insert and add and update and delete data inside of these tables, at which point you could write select star from riders and see some data you've inserted yourself. Great question. Let's take one more here.
Yes, I would like to know if you have a column data type Boolean.
Yeah, do we have a Boolean
In
type
MySQL,
affinity?
there's
Let's see it.
none.
So here,
tiny int,
we don't, at least in
0 or
SQLite. Some
1.
other DBMSs, database management systems, might have bool or Boolean, true or false, right? Let me show you this instead. If I go to my terminal, I can see, if I type .schema, I haven't used Boolean. There's no need for me in this case, but I have used integer. And
0, 1.
integer for SQLite can kind of serve the same purpose. I could have the integer 0 or the integer 1 to be true, or to be false or true respectively. 0 being false and true being 1, I believe, in this case. But good question. Okay, so to the earlier question, like we've improved our tables. We now have type affinities for our columns, but we don't yet have this idea we talked about last week, which was primary keys and foreign keys. This idea of trying to uniquely represent each item in our own table using primary keys and trying to reference that primary key from some other table using foreign keys. So let's try to work on that now.
Okay.
And for
I'm
this,
gonna stop it for now. Already 1:30 a.m. I have to go somewhere tomorrow. Yeah, there's something I have to buy. It's a drill impact. No, not a drill. It's an impact driver. I'm trying to look for it. I mean, I found one on the internet, like on online shops, but it's incomplete. They buy you the they buy. I mean, they give you the thing, right? But they don't give you everything. What I mean is that the charger is separate, the battery is separate. I'm like, yeah. And then I tried looking for the charger. I couldn't find it. Like I could find everything but the charger, and I'm like, why would you do that? why would you sell something and then it's incomplete? So yeah, I'm gonna check hardware store tomorrow. I'm looking for a power tool impact driver. Yeah, hopefully I can get all the parts that I need. Still don't get it. Like, why would you sell a power tool and then sell the parts separately? Why can't you just sell everything in, you get what I mean? Like, just one package and everything is there for that specific power tool. If I need an impact wrench, like everything is just there. Why do I need to, why is the charger separate? Why is the battery separate? You get what I mean? Yeah, it pisses me off. Like, why would you do that? Yeah. But yeah, that's my plans for tomorrow. I still have to do that. I also need to do the laundry too tomorrow. I still need to do the laundry, clean the bathroom. Yeah, and I think I'll stream tomorrow. Yeah, I'm gonna finish this. I'm not sure if I'm gonna stream SQL tomorrow. Because there's another thing that I want to stream, but the reason why I did not stream it today is because it's very late already. Like, I think it will take a while. The one that I want to stream, I think it will take more than, I don't know, 2 hours. I feel like this stream is like 2 hours and 30 or something. I'll have to check the VODs. But yeah, that's it for me. Thank you for watching. I'm actually really excited with learning SQL. I'm almost, I'm making progress. Making progress. Finding time. Also, I'm liking the setup where I'm standing. I'm still not used to it. Like my legs are like aching right now. But hopefully at some point I can get used to it. Just standing for a long time. I prefer it because my body is upright. I didn't really like sitting. Like sitting, I have to worry about my back if I'm sitting. Yeah, I have to worry about my posture a lot when I'm sitting down. But when I'm standing up, I can, it's easier to stand straight than it is to sit straight, if you get what I mean. Because like if you're sitting, like your body just naturally wants to droop. But like if you're standing, I don't know why. It's easier. Yeah, for me, at least for me, it's easier to just have a straight body when you're standing. Yeah. I also want to, yeah. In the future, I also want to do like typing streams again. Yeah. Because now I have a new keyboard, right? The as you can see, the instructor he types fast. Me, I type slow. I want to learn to type fast. Okay. I mean, I've tried before, but I forgot. I forgot it. Okay, I forgot it. It was a long time ago. I think it was last year. I streamed it. I want to do it again. Yeah. But those are my plans. So yeah, thanks for watching. I have to sleep now, guys. Bye bye. Thanks for watching. I have this thing, and I'm gonna click this and then stop streaming. Bye bye.